Hi friends, it's Mr. Rogers here. We're going to talk about dihybrids today. And I already started one video and I got a phone call in the middle of it, so I had to stop. So I already have a couple things written out. So first thing is dihybrid means crossing of two different things at once. And these are independent. So it'd be like me flipping a coin in my classroom and Urquhart flipping a coin in his classroom. They are both independent results. They do not influence each other at all. So we're going to talk about different Punnett squares later on this week when they influence each other, when one of them will affect the other outcome. But right now, we're just talking about two separate ones. Okay. So, for example, we might have a big A crossing, or big A, big B, little b crossing with a big A, big B, big B. And so we're going to end up with more boxes. Dihybrids make 16 boxes instead of 4. Trihybrids make 64. Quadrihybrids make 128. That type of thing. So we're gonna practice this. And now what I want you guys to do is I want you to think of these almost like dihybrids. Dihybrid, or not hybrids. I said that last time in the last video too. I want you to think about these like diploids. This is a full set of genes. These are full sets of genes. And so when you're doing Punnett squares, you're actually showing the haploid versions. So we want to get to half the number. We want to get each section of the Punnett square to 1A and 1B. 1A and 1B. Okay? And we can do this multiple different ways. So let me show you the first way. This is the official way. This is foiling. You did this in math class. So if I take big A, big B, little b, and I foil, focus. Why is it? Sorry, let me refocus. I don't know why I did that. There you go. If I actually foil it, F stands for first. So if I put parentheses around these guys, first, so I'll have an AB. So this is my Punnett square. I'm going to make a big Punnett square down here. So AB is the first one. Outside, big A, little b. Inside, big A, big B. And last is big A, little b. And then I have to do the same for the next one. So big A, little a, big B, big B. So I do the first, big A, big B. Outside, big A, big B. Inside, little a, big B. Last, little a, big B. Cool. So now I have my Punnett square, and now I just have to do it like normal. You combine them together. So I have big A, big B here. Big A, big B, big B. Now, I'm not going to go through all these. That's going to take too much time. But I just want you guys to see, okay, so you're just combining the two sides, and you're coming up, again, with a diploid. Because these are all haploids, and two haploids together makes a diploid again. So that's the way you foil. That's the technical way of doing it. There's other ways of doing it. One of the biggest ways is by using what's called an arrow method. Okay, the arrow method is just kind of what I did now, but it's kind of just a logic thing. So you look at what I just did between big A, big B, little b, and I think to myself, okay, each one needs to join with another partner at least once. It's kind of like if you think of these as like shirts and these as pants, how many different combinations of outfits can I make? Well, I can make this big A with this big B. And I can make this big A with this little b. And I can do this big A with this big B. And I can do this big A with this little b. Okay. And I do the same on the other side. We'll figure it out. Now, this leads to the cheat in dihybrids that make things go fast. Truly, this shirt, if I call this a shirt and this is pants, these two shirts are identical. So they're not different outfits. They're the same outfit. So, for example, big A, big B here was this A with this big B. This one right here is this A with this big B. Same pants here, okay? These are identical. So technically, I don't need this line right here in the Punnett square. I can get rid of that line. If I actually make Punnett square. These guys are the same too, so I can get rid of this line. So it ends up being only 8 boxes. And if I do the other one with my arrows, so big A, big B, well, big A can go with that one. It's identical if I go to that one, so I'm not even going to write it. And this guy can go to that one. Identical if I go to the other guy, so I'm not even going to write it. So all of a sudden, this Punnett square got a lot smaller. I don't nearly have to do as much. Light one off. There we go. So I only had to do 4 instead of 16, and that's a lifesaver. Let's be honest with ourselves. That saves a lot of time. So each one of these genotypes is different. Phenotypes, none of them are different. They all have at least one big A, one big B. So that means phenotype-wise, they're the same. I never really went over what they all represented, but I just wanted you to see. So that's the way to get rid of it. You can do the same thing, obviously, with foil. Like this one was identical with this guy, so I could have got rid of this line. It's the same question, so you're going to end up with the same amount of boxes. Get rid of this one. I could get rid of this guy right here and this guy. So it's 1, 2, 3, 4 boxes. So always look for identicals, and you can get rid of them and make the question shorter. So we're going to practice some dihybrids. If you need more help, obviously get a hold of me, and I'll give you some help. There's also always some videos online you can look up, but I think this was a good explanation, and I also showed you the cheat. So you can use either the foil method or the arrow method. If you need, like I said, any more help, let me know. I'll talk to you guys later.